Hello, good morning all. Today we are going to discuss about molecular motors and their prototypes. In this session, we are going to discuss about what are the molecular motors and what are the prototypes of molecular motors. At the end of this session, students can understand about how this molecular motors functioning and they know what are the applications for their molecular motors. Now let us see what is the definition of a molecular motor. Molecular motors are like a molecules. Molecular motors are the molecules which are capable of rotatory motion. That means these molecules are moving or change their direction or shape or structure with the help of energy or light or radiation or any environmental medium like acid or basic medium. And here we observe two types of bond rotations in these molecular motors. So here this single bond rotatory motors generally observed by chemical reactions. That means redox reactions or acid base reactions. And double bond rotatory motors can be observed and these can be fueled by the light. That means with the help of light these molecules change their structures. Like we observe some types of radium stickers. Those type of stickers are manufactured with this molecular motors. And this rotation speed of the motor can also tune for a beautiful molecular design. And these molecular motors contains two parts. Those are mobile and another one is stationary parts. One is mobile part and second one is stationary part. So these machines contains components called gear and brake. And here we understand that this gear is nothing but a mobile component and this brake is considered as a stationary part. Let us take one example here. This is an example of rotaxane. This is an example structure for rotaxane molecule. And here we observe gear and brake components in this structure. So these steric components, these steric crowd act as a brake, and these star-shaped structure act as a gear. So this is the way we understand the molecular motor identification. And now coming to the different types of prototypes. That means with the help of acid or with the help of light or with the help of energy, these type of molecules can change their structures or they can change their physical and chemical properties. And now coming to these prototypes, here these prototypes are four ways we can consider. In those, first one is linear motion in rotaxanes. First one is about a linear motion. This linear motion is happened because of redox reactions or a protonation or deprotonation steps. That means we can understand that by chemical reactions, by this type of chemical reactions, we understand linear motion in rotaxanes. And now coming to the second one, this is about acid-base controlled molecules. Like indicators generally we observed in acid-base titrations. We can understand these indicators are the acid-base controlled molecular shuttles. That means with the change in the pH of the medium, these molecules can change their color with the change in their structure. For example, phenolphthalein is there. It is colorless in acidic medium, but it shows pink color in basic medium. So that we understand that phenolphthalein is a molecular motor in pH medium. So we can consider that is an example for acid-base controlled molecular shuttle. And third one is molecular elevator. This means here molecule is moving either upward or downward with the help of change in the pH of the medium. When the change of the pH, what happens? The molecule exists on a component, it will be moving either upward side or it will be moving towards downward side. And fourth one is an autonomous light powered molecular shuttle. That means with the help of a light like photochemical reactions, that means we can using either UV light or visible light or polarized light. With the help of these type of lights, the molecule can change the structure of the substances. Now let us see one by one. First, let us see linear motion in rotaxanes. And again, this linear motion we observe in two ways. First one is translation motion. First type is translation motion. Here, this motion we observe when these two brake components are identical. When these two brake components are identical, we observe translation motion. So in this translation motion, what happened? This ring, this center ring is moving like this direction or this direction with the help of interactions exist with these brake components. With the help of brake components of the interactions, this ring will moving either right side or moving left side. So that movement we observe as a shuttling of the ring along the axle, and we consider this is the axle, this ring is moving in this direction. And coming to the second case, here we observe rotational motion. In this case we observe rotational motion, where we observe here this brake component are different. When these two are in different motions, that means one is in a small size and second one will be a larger one, and here the ring will be happen like this way. When we observe this ring, center ring will be moving in this direction as a wheel. So here this rotation of the macrocyclic ring, this is the macrocyclic ring, is moving around the axle. So this is the first type of linear motion. And coming to the second type, acid base molecular shuttle. So previously I said that phenolphthalein is a indicator and which changes the color in acidic medium as well as in basic medium. So how this change happen? Let us see. First we observe the phenolphthalein structure, and when this phenolphthalein structure in acidic medium, generally it is a colorless compound because this ring is closed. In this case the ring is closed, so that this is a colorless compound. But this compound we add in base medium, that means we add in a basic medium. Here this ring will be open, here this ring will be open here, and here the bond will be break down and this hydrogen will come outside and form as H3O plus. Here this hydrogen will be come outside when it enter into the basic medium. This hydrogen come outside and this hydrogen with water, and it produces, these two produces H3O plus. So because this orientation happen and the ring bond will be break down in a ring structure, here ring will be open, so that we observe a pink color in phenolphthalein. So now let us see how to draw this structure. So just I take an example, let us see how to draw this phenolphthalein structure, because it's a complicated structure. Is it difficult to remember this type of structures? So there is a small technique is there to understand or to remember this thing. So here first let us start with the first one with a carbon. So we first draw this first one as a carbon. We know that carbon valency is 4, so that we give 4 bonds like this way. Here we are giving 4 bonds like this way. Okay, first carbon we draw, then we give 4 bonds, and now understand the benzene rings surrounding this molecule. We understand that 3 benzene rings are there, so that we can give benzene rings in so like this we give benzene rings first, then we understand 2 OH groups. So first 4 bonds we kept there, and now 3 benzene rings we are going to draw, then 2 OH groups will be adding there. So here OH and OH, and here 2 OH groups we kept like this way. So 3 benzene rings and then go for 2 OH groups. Now let us fill the bonds, that means the double bonds in the ring. So here I just randomly give the double bonds here. So randomly I am giving double bonds here, and now I just complete the structure right now. So again I take another carbon which is interlinked with this benzene ring and with oxygen. That means I take one carbon here and oxygen here. And also we know that this carbon also contains 4 valence, so that I give 2 double bond here, 1 double bond here. So that I am giving another double bond at downside of that carbon. And this oxygen valence is 2, so that it is bonding with this one. So here this like this way, this single bond, and here C double bond O will be formed. So this is the structure of phenolphthalein in acidic medium. Now how it will be changes into basic medium? This hydrogen will come outside. When this hydrogen come outside, what happen here? This bond will be breakdown. This bond will be breakdown, and here double bond will be generated. This bond will be moving like this, and hydrogen will come outside. So let us see how to draw this structure. So again I draw center C, and again I am giving 3. I have to give 4 double bonds, 4 bonds, 4 single bonds, but here I give 2 single bonds and 1 double bond here for draw this structure. And now here this benzene ring doesn't change here. This benzene ring doesn't change here, and here also benzene ring doesn't change, so that we draw as it is. Okay, and here what happened? From here C double bond O will be there, but here O minus will appear. O minus will be appear because here bond will be break. Here this bond is broken, so that we write like O minus, and here C double bond O will come, and again this is connected to a benzene ring. So one thing we have to understand, that if you observe a double bond for a ring on outside, we understand only 2 double bonds in the ring. So I give at opposite directions, and one more double bond will be formed outside of the ring, and here O will be come, and that hydrogen is removed from here. This hydrogen is removing outside and formed as H3O plus. So in this way we can draw this phenolphthalein structure. And now coming to the next example, and this is the example of acid indicator. So here we consider methyl orange is an example. In this structure what happen? In acidic medium it will give color, in basic medium it will appear as a yellow color, and this is the structure in basic medium where we observe yellow color with the lambda maximum, that is the wavelength. That is the wavelength of the substance 460 nanometers. And when we are adding acid, that means we are adding this molecule in a acidic medium, protonated substance will be developed. So protonated substance will be developed. So in this protonated what happen? Here positive charge will be developed. Positive charge will be developed. Because of this positive charge exists on this nitrogen, we observe a red color with the wavelength of 520 nanometer. So color shift from yellow to red when the medium of the substance changes. That's why we consider this is a acid base molecular shuttle. Now see how to draw this methyl orange structure. How to draw this methyl orange structure, let us see. So first, for this type of compounds, start with the N double bond N. Start with N double bond N. And here 2 benzene rings give on both sides. 2 benzene rings give on both sides. 2 benzene rings give on both sides. And next, understand that north pole and south pole, that means nitrogen and sulfur. So one side give nitrogen and another side give sulfur. And after this, balance the valency. For sulfur, we have to maintain 6 valency, so that we are adding 2 double bond oxygens and 1 single bond and Na plus. That means here overall how many bonds are there? 2 plus 2, 4, 6. So sulfur has 6 valency, and this O is coming as a negative charge with the sodium salt. So this is the sodium salt of methyl orange. And when you are doing this acidic medium, means protonation, what happen? In this structure, this N double bond N, gets protonated form and the remaining thing are same. No change. That means no change. We observe there is no change when you observe a protonated form on the N double bond N. But here hydrogen will be attached. So protonated form will be appear with along with the hydrogen. So this is the structure of methyl orange in acidic medium. This is the second type of prototype. So in second type of prototype we observe two examples. One is phenolphthalein and second one is methyl orange. And now coming to the third one, that is a molecular elevator. This is also changes happen in the presence of acid or basic medium. So here we observe this pink color rings are the small molecules. Pink color rings are the small molecules which are moving in tripod shaped molecules. Moving in tripod shaped molecules. So this ring is interactions with the tripod shaped molecule. So suppose if this molecule we keep it in a basic medium, these rings come downward or downside. It will come to the downwards when it is in a basic medium. If it is taken in acidic medium, this ring will be moving upward direction. This ring will be moving upward direction. So drawing of this structure is very easy. So first start with the one tripod stand structure. First draw one tripod stand structure and give some rings at the corners of the thing and give in alternate positions like this way. Okay. So now let us now give the pink color ring right now. Now give the pink color ring like this way. So in this way we can understand or plot the structure of this molecular elevator. So next one is about autonomous light powered molecule. So earlierly saying that because of this light changes, compound will be changes. For example, here we are taking an example dithionyl ethane. Here we take an example dithionyl ethane. And here we observe a open structure and a closed structure. Here we observe a open structure and a closed structure. This open structure we observe in visible light and this closed structure we observe in UV light. So UV light lo ala untundi. Coming to the visible thing, ring will be open. So when the ring has opened, what happened? It is observed as a colorless compound. But in UV light, it observed in a colored compound. Like some cases we observe that in a UV light presence, compounds changing their colors. But actually in visible region, that means in an ordinary light, we don't observe any type of color. But the same compound, if you take in a UV light presence, you observe some type of colors. So this is the best example for the type of molecule. Now let us see how to draw this structure. So here I take an example how to draw this dithionyl ethane. So first I start with the 5-membered rings of 3 rings. So 5-membered rings on the 3 consider, we have to consider 3 types. So first one I draw like this way, and second one I draw, third one I draw like this way. First I draw 3 5-membered rings as a triangular form. And now here I give one bridge bond of alkyl 6 groups. Alkyl 6 groups. And here we joint like this way. And here give one sulfur here and another sulfur here, and give double bonds in this cases. In double bond in this cases. And here we give just like R and like R and R. Like this way we can give like this the structure, and here will be double bond will be exist. And here you can consider R or any type of hydrogen. But here what happened, this bond will be moving like this direction. So here bond will be like this opposite direction, like a hands, how it will be moving like this way. One hand downward and another bond angle will be upward side. Like this way we can draw the structure. This is in visible light, which is the open structure. Now coming to the closed structure, what happened? So coming to the closed structure, so only thing happen, new bond will be developed in this position. So new bond will be developed here. So how it will be developed? This bond moving this direction, and here already exists double bond moving this direction, and this bond will be moving like this direction. In a triangular way it will be moving like this way, so that bonds will be changes or rotation happen here. So finally we understand this structure like this. Here will double bond come here, and another double bond will come here, and here this one molecule is moving like a wedge shape. That means this is inside the into the board, and this is hanging before the board. So these bonds will be moving. It is in a deep side of the structure, and this is come outside of the board. Okay, so in this way we understand the structure of this molecule. And the last molecule about this example, here we observe another example is a hindered alkane, and here we observe CPL, that is LCPL, that is circular polarized light. Circular polarized light. So in light, left circular polarized light and right circular polarized light. Okay, so now we conclude here. The remaining thing we will discuss in next session. Thank you all. Yes, the second example of this light powered molecular motor is hindered alkene. So coming to this structure, here we observe 3 rings on top side and another 3 rings on down side. One special ring will be adjusted at first ring of the upper side, and here one oxygen and sulfur will be exist here. So this is happen in the presence of CPL, that is called circularly polarized light. It is called circularly polarized light, and left and right side we are using. So this is the left side structure and this is the right circularly polarized light. So when we pass this left circularly polarized light, we observe this structure, and if you pass right circularly polarized light, we observe this structure. What is the difference between these two? This ring only the difference. Like how this appear, for this molecule we consider hand like this way. This is the ring will be moving to another side. So this is the first molecule structure. This is the thing as considered as a thumb, and when now we pass the light here, so that this molecule moving in this direction. So this side ring will come to this side. So this is the thing we observe here. This is the thing we observe here. Now let us see how to draw this thing. So first, as I said like that, first draw the 3 benzene rings. Okay. So first draw 3 benzene rings here and give one oxygen at top side and one sulfur at down side, and give a bond between these 3 rings as a double bond, and now fill up the double bonds in the structure. So already one double bond come outside, so that only 2 double bonds will exist in the center benzene ring like this way, and for this ring it will become in opposite directions, and here the thing will come like this way. This is the another structure, and now when we change the light, this ring will come to this direction. So this way we can draw this type of structures. In next session we will see what are the applications of these prototypes of molecular motors. Generally these are used in catalysis as well as in diagnosis of different types of tumors by their functions. So that's it for today. Thank you all.